Thank you, Epic, for having me. I am speaking on behalf of FEMTOprint. We have recently done a successful collaboration with 3D AG and FHNW, wherein we leveraged FEMTOprint's technology to structure glass to ultimately produce products, microfluidic devices on a plastic substrate. And I'll explain how we accomplish that. Start by giving an overview of our company and then kind of focus on this project that we did. So we are a Swiss company located in the south of Switzerland with 40 plus team members. We export worldwide and we are ISO 13485 certified, which is of particular relevance for the medical device and life sciences market applications. I'm specifically responsible for supporting microfluidic and life science applications on behalf of the company. And I'm located in San Diego, California. We are definitely a growing company. We have just recently onboarded another American to support optics and photonics operations in the United States as well. So a very stable and reliable company to partner with. The way our technology works is we start with a design as illustrated by this three-dimensional T on the left. We take this step file, this design that is provided to us, and we use that to directly write with our femtosecond laser onto a bulk substrate of glass. So we specifically focus on glass as a substrate. This laser writing creates a weakness in the glass that we can then selectively etch away. And so this is how we produce features on glass. And the benefits of this technology are that you can really have a lot of design freedom as illustrated in this zoomed in picture on the right. We're able to achieve, as an example, multi-depth features within the glass substrate in one step of production, which is something that you cannot achieve with traditional manufacturing techniques such as wet etch photolithography. Also, because this is a maskless process, we're able to have quite quick turnaround times, which is critical for the prototyping stage of the development project. Using our technology, we are able to create these comprehensive devices. So we are able to create 3D features in glass. We can also directly write waveguides into a glass substrate using our lasers. We also are able to laser weld two pieces of glass. So for microfluidic applications, this is critical because we typically etch the channels into one piece of glass and then cap it with another piece of glass. The first question that people typically ask is what our resolution is. And so we can get down to 1 micron resolution with a tolerance of plus minus 1 micron in the XY direction and plus minus 2 microns in the Z direction. For those of you guys that have optical expertise, you're probably curious about the surface area roughness we can achieve. Following our machining process, we can achieve a surface area roughness of 100 to 300 nanometers, but we can follow that with a polishing process that can get it down to 10 nanometers. And my background, I've come from a wet etch photolithography company and an injection molding company. So one of my favorite capabilities of ours is that we can achieve these really high aspect ratios with our technology that you really can't achieve with other technologies. And we, as I mentioned, we support a variety of industries. We are not specific to microfluidics and life sciences, which is under my purview, but we support a variety of industries, which really allows us to approach problems with very unique lenses, and we can develop creative solutions to the challenges that our customers present to us. Now to present on what specifically we are focusing on today is using our technology to create glass masters for replication technologies. And we did this project in collaboration with FHNW, University in Switzerland, and 3D AG. And the way this project unfolded was a three-step process wherein FEMTOprint was responsible for the first step in creating the glass master using our laser-assisted etching technique. Subsequently, we worked with 3D to create a nickel shim, which ultimately could be used in tooling at FHNW to injection mold a plastic device. And I'll delve further into that. Now, the advantages of using our technology to create a glass master is, as I highlighted previously, you have a lot more design freedom using our technology. You can create multi-depth channels, you can create sloped channels, you have a higher aspect ratio that you can employ. Very critical to the demolding process for replication technologies is the inclusion of a draft angle so you don't get that Velcro effect when removing the plastic from the mold. Additionally, using our technology, you can create this prototype in glass while also creating the tooling in parallel. So this makes the development phase of the project a lot more efficient. So you can make this exact replica in glass for prototyping with a fast turnaround time that you can then also use for your tooling. So again, following the creation of the glass master by FEMTOprint, we partnered with 3D to create the nickel shim. And this was done via an electroforming process. And this process creates an exact replica of the glass master onto nickel. Another advantage of this process is that you can create multiple nickel shims out of one glass master parent. So this effectively produces a family of tooling at a much more economical price point. And the last stage of the process, in order to demonstrate the effectiveness of the glass master and nickel shim process, we had to prove that we could injection mold using the nickel shim. And so we partnered with FHNW to do this, and they were able to successfully mold our designs on various substrates. So they were able to do this in COC, COP, and PMMA, and they were able to utilize various injection molding processes. So overall, we were able to start with our technology to produce a glass master and ultimately successfully produce microfluidic devices on a plastic substrate. And I would like to thank Merrick and Magnus at 3D and FHNW, who worked in conjunction with Andrea at FEMTOprint to successfully achieve this project. And if you guys have any questions, please let me know. I have obviously my email up on the screen, and we also have just published a white paper specifically on this project that will go into further detail if you guys have any questions. Thank you.